Today we talk a little bit about linear equations, intercepts, and zeros. So the first thing we're going to do is we're going to graph the equation 4x plus 5y equals 15. And we'll go about it the way we learned in Algebra 1. We'll isolate y. So I have, get my pen going. I've got 5y equals, I like putting my x's first, negative 4x plus 15. Divide both sides by 5 so we can isolate my y. So y is equal to negative 4/5 x plus 3. And then we've got a multitude of ways that we can take and graph this from here. We can pick points. And if I were to pick points, I would pick x values that had a multiple of 5, so this denominator would reduce out. Or we can use what's known as the slope-intercept method, y equals mx plus b, where b is the 3 and m is the negative 4/5. So I'm going to do that. Go up to 3, put a little dot there, and from there go down 4 and over 1, 2, 3, 4, 5. Put a dot there, and I can do it again if I wanted to. 1, 2, 3, 4, and 1, 2, 3, 4, 5. And basically draw a line connecting those dots. See how straight I can make it. Going in both directions-ish. Okay, and there's a general sketch of that graph. Next, we're going to take and graph this complex equation using something called intercepts. We've got two we're going to look at. We're going to look at an x-intercept and our y-intercept. Now, if we take a look at any general graph and look at the properties of the x and y-intercepts, this is my x-axis, so this point here is my x-intercept. We know that for any point on this x-axis, our y value is actually 0. And this is my y-intercept where it intersects the y-axis. We know that any point on this axis has an x-coordinate of 0. So let's write that down. For our x-intercept, we're going to take and set y equal to 0. And for our y-intercept, we're going to set x equal to 0. So getting to this equation now, if I want to find my x-intercept, I'll simply take and set my y equal to 0. So I have 25x plus 70 times 0, since y is equal to 0, and that's equal to 350. All right, 25 x equals 350, and that goes in right around 14 times for x. Now, if I want to find my y-intercept, again, we're just going to take and set my x equal to 0. So I have 25 times 0 now, plus 70y equals 350. Isolate 70y equals 350. And y is going to give me 5. Sketching a graph of this, and I'll do it just very roughly. My y value is 5. My x value is way out here at 14. Put a dot on either one of those guys. And draw a line going through those 2 points. Wish it were straight, but so be it. Moving to the next example. All right, so next we talk about slope. We already did that a little bit. We know the slope's defined as our rise over run. which is also expressed as change in y over the change in x. And when we talk about changes, we talk about a difference of two things. So y2 minus y1 over x2 minus x1. Nothing different than you saw in Algebra 1. Slope-intercept equation we talked a little bit about already. Y equals mx plus b. M is the slope, and b is the y-intercept. So using that, we're going to take and write the equation of a line passing through the given points. So if we want to do this, we're going to first have to find our slope. M is equal to the change in y's over the change in x's. So I'm going to take 7 minus 4 and put that over negative 2 minus 8. Gives me a negative 3 on top, or actually that's a positive 3. And on the bottom I get a negative 10. So now I have y equals negative 3/10 x plus b. Next, I'm going to have to find out the value for b. To do this, I can take either the 2 points, the 8 and the 4, or the negative 2 and the 7, and plug them in for x and y. It really doesn't matter, so I'm going to take the 8 and the 4 since it's first. So 4 is my y value. That equals to negative 3 over 10 times 8. It's really 8 over 1, so I'll just put that for kicks, plus b. These will reduce out. 4 here, this goes in 4 times up top, 5 times on bottom, giving me negative 12 over 5 plus b. And b is equal to, what, 32 over 5? When I add that over. So my equation for the line in slope-intercept form is y equals negative 3/10 x plus 32 over 5. And that's my guy. Moving to the next level, we want to take and write the equation of a line passing through the point negative 3, 5, and is also parallel to a line with the equation of 7x plus 2y is equal to 4. So we've got to talk a little bit about parallel lines. Okay? And from Algebra 1, we know parallel lines have the same slope. So if that's true, we're going to need to find the slope of this equation first. And the easiest way to do that is put it in slope-intercept form. So let's do that, isolating the y. I have 2y is equal to negative 7x plus 4. Y by itself so we can find our slope. So y is equal to negative 7 over 2x plus 2. Slope then is the number in front of the x, or in this case, negative 7 over 2. That means the parallel slope equals negative 7 over 2 as well. Therefore, I have y equals negative 7 over 2x plus b, and like in our previous equation, we're going to take the x and y values from the point negative 3, 5 and plug those in. So I have 5 equals negative 7 over 2 times negative 3 plus b. This is 21 over 2 plus b is equal to 5. Once I know that, I can subtract 21 over 2 from the other side. Gives me negative 11 over 2 equaling b. And my equation of the parallel line is y equals negative 7 over 2x minus 11 over 2. Let's move to the next example. Now in this case, in reading the equation, we find out we're talking about perpendicular lines. All right? We know perpendicular lines have opposite reciprocal. Eek. Opposite reciprocal slopes. Great. And luckily in this case, we've already been given a slope of our equation. So my perpendicular slope is the opposite reciprocal of negative 4/3. Well, that's positive 3/4. Therefore, the equation of my line is y equals 3/4 x plus b. And again, as in our previous examples, we're going to take the x and y's from our given point and plug those into the equation. So substituting, I have 4 for my y is equal to 3/4 times an x value of 20 plus b. 20 and the 4 reduced to 5. 3 times 5 is 15. Whoops. Sorry, guys. That's a b. So 15 plus b is equal to 4, and negative 11 is equal to b. Now all I have to do is write the equation of my line. So I have y equals positive 3/4 x minus 11. Couple more. Next, we're going to write the equation of a line passing through the point 1,8, perpendicular to the line with the equation of x is equal to 14. Now, a line with the equation of x equals 14 is a little bit different because that's not in slope-intercept form. We have to remember that any line with an x equals equation is a line such that all x values are equal to negative 14. So if this were negative 14, the line that I'm going to draw has an x value of negative 14 for all of its points, which means it's a vertical line looking something like this. Now what we want to do is we want to write the equation of a line that passes through the point 1,8. Well, where is 1,8? Now let's call it right here. Now if we want to write the equation of a line passing through that that's also perpendicular, then I've got something like this. All right, which there's a horizontal line. Horizontal line, there's also something that remains the same all the time, and in this case, it's the y value. And we can write the equation of that line by just describing it as its y value. So in this case, every y coordinate is 8, so my perpendicular line has the equation of y equals 8. No slope-intercept stuff necessary. That's about it for today. So you're going to go to the forum, answer the following questions, and we'll see you tomorrow.